All right, I want you to think about this one. If you flip a coin 10 times, what is the total number of outcomes? So 2 to the 10 is equal to 1,024 because there will be 2 to the power of 10 possible outcomes. And it relates to the rows in the in Pascal's triangle. So for B, how many outcomes, so the probability of A, so this in this case, the number of situations where we can get probability of getting all heads is going to be one event because there's only one way we can get all heads out of 1,024 events. Okay? So now C, now how can we do this quickly? If we go down to the 10th row, okay, we can actually figure out how many ways can we get one head. One tail. 10. So the probability of getting one tail is there are 10 events where we get exactly one tail, and there is still 1,024 possible events. Okay, the probability of getting exactly two tails. So go down to Pascal's triangle again. So 45. So this would be 45 out of 1,024. Okay, and then find Pascal's triangle and do the next two. So the probability of getting three tails will be 120 possible ways of getting three tails. Out of 1,024 possible events. That reduces. $15. So we could do this a couple ways. We could do this as 10 choose 8 plus 10 choose 9 plus 10 choose 10. Add those all up, divide them by the 1,024. Or in this case, what we could do, so the probability of greater than or equal to 8 tails can be from our last three numbers in the 10th row of Pascal's triangle here. Okay, there's our numbers there. So it's going to be 45 plus 10 plus 1. And this is 10 choose 8. This is 10 choose, 10 choose 9 and 10 choose 10. We divide that by the total possible number of outcomes, which is 1,024. And get 56 over 1,024. But that reduces to 7 over 128. Good. All right. Now, talk about the number of ways we can get, and you can only move diagonally. So we can start up here, we can move diagonally down, and that's it. Okay, so how many options do I have to get to here? 1, okay? And by the same token,
Excuse the interruption, but would Riley Bruton please come to the office as well as Jordan Morin? Thank you.
How many ways can I get to this S by moving only diagonally? 1. How many ways can I get to the C moving diagonally? It's just one way. So in every case here, there's one way I can get to here, one way I can get to here, one way I can get to here. Okay? Same over here, going down, one way to get to here, one way to get to here, and one way to get to here. Now, what about to get to this S? How many ways? 2 ways, because I can go to this A, then to this S, then, or I can go from P to this A to this S. So there are 2 ways I can get to that S. Now, if there's one way I can get to this S, I can get to the C that way. How many ways can I get to the C here? So there's going to be 3 because there's 1 and there's 2 and there's 3, which is just 1 plus 2. All right? What's this one going to be? 3. Okay. What's this going to be? 4. Okay? 3 plus 1, which would be all the combinations, all the possible routes to get to this C, which would be down here, then down here, down here, and then down here. This one would have how many possible ways to get to this A? 6. How many ways to get to this A? 4. To get to this L? 10. And to get to this L? 10. So the total number of ways we can spell Pascal using this shape, 20 ways. All right? Okay, here's a checkerboard. I want to know how many ways I can get from this point here to the end. If you've ever played checkers, you know when you get crowned, get to the end of the board. And the only thing I can't do is go through this spot here. Okay, so I can move diagonally, and I can't move onto any green space. Okay, I can move diagonally just like in checkers. And so I want you to start thinking about how many ways we can get to each one. So sketch that and picture it the same sort of way. Can checkers move backwards? Okay, but we've got to get to the end, so we can't move backwards until we get to the end. So that's not going to come into our example. So we can't go from here to here. All right. So we'll start off with the first easy ones. It's going to take. There's one way we can get to that square. There's one way we can get to this square. One way to get to that square. One way to get to that square. One way to get to that square. And one way to get to that square. Okay? Now, how many ways can we get to that square? 2. And how many ways can we get to that square? 3. How many ways to that one? So 1, and then 1, and another 1. So 3. Which will be just 1 plus 2. And to get to this one will be 4. This one will be 4 as well. Now, how many ways can we get to that one? 4. And how many ways can we get to that one? Because it's going to be 4 as well. Because the only way we can get there is, we can't get to there from anywhere else. This will be 4 ways to get to there. And that'll be 5 ways to get to there. That'll be 5. This will be 9. This will be 8 and 8. So the total number of ways that we can get the checker to the end of the board is going to be 16, 25, 30. So 30 ways.